Here again we're going to solve a system of nonlinear equations algebraically. We can use substitution or elimination. In this particular problem we're going to use substitution. We're going to start by solving our second equation here for y. We're going to get y is equal to x plus 1. And we're going to go ahead and substitute that into our first equation for y. So we're going to get 2 times x plus 1 quantity squared minus 3x squared is equal to 5. If we go ahead and square this out, we'll have 2 times x squared plus 2x plus 1, and then minus 3x squared is equal to 5. This gives us 2x squared plus 4x plus 2 minus 3x squared is equal to 5. This will give us negative 2x squared, negative x squared plus 4x, and then we'll have minus 3 is equal to 0. If we go ahead and multiply through by a negative, we'll have x squared minus 4x plus 3 is equal to 0. We have a quadratic equation. We'll go ahead and try to factor this. We'll get x minus 3 times x minus 1 is equal to 0. If we set each factor equal to 0 and solve, we'll get x is equal to 3, or x is equal to 1. We're going to use these two values for x back up here in equation 2 to solve for y. If x is equal to 3, we'll get y is equal to 3 plus 1, which is 4. If x is equal to 1, we'll get y is equal to 1 plus 1, which is 2. So we get two ordered pair solutions to this system. Our solutions will be 3, 4, and 1, 2. Again, it doesn't hurt to get a visual representation of the situation. Our first equation is the graph of a hyperbola. The second equation is the graph of a line. We'd like to consider the possible solutions that we could get. We might get no solution, or one solution, or two solutions, as we did in this case.